Hello everyone, my name is Anwar,
My name is Leonard.
and we are your TAs for this course. Today, at the request of many, we will go through the Python Quiz 1 step by step to help you understand how to approach this kind of problems.
So first, we have our own file from the E3, which is the template.py. And so the first task is we need to construct a dynamic truth table, and we are not allowed to use external libraries and modules, which is truth modules. We cannot use that, and we are not also for that we need to define function that takes the argument. Let's look at what we are given. So the first thing is to use sympy logic operators. Simple enough. There is ampersand, there is pipe, and there's tilde, which are already inside the given propositions. Now we only need to construct for the two variables case, which means there are only gonna be 4 rows: true, 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 false, false, true, and false, false. So let's go ahead.
So let's go ahead and define our first function. Some of you said that you don't know how to define a function, so first thing we want you to understand is that coding involves a lot of Googling. When you go look for a job and it's your first day, no one will babysit you. You'll have to learn it by yourself and you will have to do it fast. With that being said, let's look up how to define a function. Leon, go ahead and look how to define a function.
Define. So you can see here, like the syntax for defining a function is basically just def, define, and then this is your the function name, and then this is your parameter. It takes your parameter. So the parameter in our template.py should be the proposition, which is a string.
So let's go ahead and define our own function named truth table. So here it will take a compound as a parameter, and also because we needed to use sympy operators and sympy logic module, we will define two variables, p and q.
P and Q equals. So here we have the in the tutorial we have the tutorial we gave before. We have the sympy library, which is we import it as sp, and then simply use symbol, and then this is your
Okay, so the second step is to parse the string to the function and then be able to process it.
So if you check about the regex, as we suggested in the announcement before, you would know that here we use regex. Now we can see that all the compound propositions, this one here, are made of smaller propositions, atomic propositions, and they are all encapsulated in parentheses. Let's see how we can match everything that is inside the parentheses with regex. For that, we will again use Google. We just Google it and regex and use regex 101. So regex. So here you insert your regex expression, and here you can type your string, and it will check like is it matched, like is it correct or not.
Let's go ahead and paste the propositions inside the regex 101.
Here.
Okay, I think this is enough. Now let's go ahead and check and Google how to match everything between the parentheses.
regex match. Okay.
Let's open the first link. Okay, now we scroll down. Okay, let's try this regular expression. It's the first one. And here you go. Here you matched everything inside the parentheses. Okay, so the regular expression seems to be working, but how do we obtain all the matching groups that we get from the string in Python? Let's Google that.
Okay. Type regex find all. This is fine. And then let's check the first one.
So, see, we have two methods to use. Find all and find iter. Let's use find all.
Final is this one here. So we do is
So now you can see that we're defining an atomic proposition. This will be a list of all matched regex expression inside our parsed string. Okay?
so here we use we put here like for the second parameter you put the strings that we have, which is our proposition, and we pass the argument which is our propositions to our function. So here our argument is called compound.
Okay, now let's check and debug this function. For debugging purpose, we will comment every other truth table call.
So for now we use proposition 1 as our example.
Let's see what we got. Here we have lists of atomic proposition of the compile proposition. Okay, this is working good. Now let's go ahead and see how can we construct the all possible values for truth table. Okay, we'll scroll down, and here we got our first result. Let's copy all of the code. And because we need only 2 variable case, we'll replace n with 2. Now let's go ahead and print the table and see what we have. Okay, sure enough, we have false, 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 true, true, false, and true, true. This is good. Now we need to iterate through all of these possible combinations. For that we will use for loop. So now we also define the list to store the entire truth table. And as we already said, there is a function enumerate. It will provide you with 2 values. First one will be index and the second one will be value of your list.
So what we do, for index and entry in enumerate of the table column, and then since table has 2 elements each
has a form of tuple,
so we do this table.
We assign values of true and false to P and Q. Now we also need some lists to store the results.
Say we put an empty list as with the name result, and
now we also need to iterate through all the possible atomic propositions.
For that we use another for loop. You can do it maybe in another way. Say expression.
Okay, right now in this nested loop we're gonna evaluate the result of the compound of the atomic propositions for each possible values of P and Q.
So our result is an empty list. We append it, and for this we use simplify. So simplify is a way
to evaluate the expression.
The expression. Simplify.
And if you looked up the hints, there is also a method called subs, which you can use to evaluate the specific values of P and Q.
So here, simplifies dot subs.
And then subs accepts input in the form of dictionary. So here you can see that we will substitute every result of P for the variable P and every result of Q for the value Q. Let's go ahead and print the result. Okay, sure enough, here we have false and true, true and true, true and false, and true and false for all of our compound proposition, for all our atomic proposition results. So now we also define the list to store the entire truth table.
For this you can use another empty list.
And now we will append our P and Q, also the result of each atomic proposition, and also the result of evaluated compound proposition.
And the last one is our compound proposition. So this one here is our P and this is our Q. This is our
atomic proposition.
and this is the compound proposition, the final. And here we use a same method as before. Dot subs. Let's check. It should be
Looks good.
Should be okay, right?
Yes.
Did we miss anything?
No. Now let's go ahead and print our data.
Okay.
Now, if you can see, we have lists inside of lists. This is because some of the compound propositions, they form lists inside the result. And to flatten our nested list, we're gonna use Google again. Let's go ahead and search Python unlist and nested element in the list.
Yes.
Sure enough, the first one. They recommend to use chain from iterable function from the model itertools. Let's do that.
So data.
Then, because we need to flatten each row, we're gonna address it with the index that we have,
So remember
the main index.
So remember we have enumerate, which results in the index and the entry. Now we use the index here for the indexing. And so please not change.
Because we still need to convert the final result to list, we're gonna use list method. Then we check if the instance inside of the list is actually a list, and if it is a list, we will flatten it out. If it's a boolean or some other type of variable, we will just ignore it.
So here we can put another for loop, but it's just a
list comprehension. You can look it up in Google.
It's a different kind, just different form. It works the same. Is say it's instance, and then if it's a list, then else I for I in data index. Did I miss anything? Change immutable.
Now let's go ahead and print our data.
Select them. Sure. Let's see. We're missing something. Chain from iterable. If it's instance. Else. I for. Should be okay though.
Let's run.
Still. Did we import itertools? Yeah, we have itertools.
For I in data.
Ah. Let's see.
Now sure enough, here you can see that all of the nested lists were converted to the ordinary lists. Now all we left to do is just print our table. For that we will use tabulate function as provided in the hints, and we also gonna need headers. So to have a dynamic headers, we will also need to define a list of headers and place it inside the for loop. So the initial headers will consist only of P and Q.
And so the first one is P and Q, and then the second one should be our atomic proposition. We know that the atomic proposition is here, the result. So in this for loop, in this nested for loop, you can append and put our expression inside. And we have our atomic proposition appended. And we have our atomic proposition appended. And the final one should be our compound proposition, which is, you can put it, yeah.
Now to print the final result, we will need to step out of the for loops. Let's go ahead and try to print our table.
We use tabulate.
Let's check the final result.
Fingers crossed.
Oh, here you can see. Here's our truth table. Easy peasy.